In this video, we are going to see about the types of statistical tests in hypothesis testing. Broadly, the statistical test has been classified into two main categories. 1. Parametric test. 2. Non-parametric test. What is parametric test? Parametric tests are the ones that can only be run with data that stick with the three statistical assumptions. 1. Independence of observations. 2. Homogeneity of variance. 3. Normality of data. Parametric tests will be able to make stronger inferences from the data. The most common types of parametric tests are divided into three categories. 1. Regression tests. 2. Comparison tests. 3. Correlation tests. 1. Regression tests. These tests are used to test cause and effect relationships. If the change in one or more continuous variable predicts change in another variable. Simple linear regression. It tests how a change in the predictor variable predicts the level of change in the outcome variable. Multiple linear regression. It tests how changes in the combination of two or more predictor variables predict the level of change in the outcome variable. Logistic regression. It is used to describe data and to explain the relationship between one dependent, binary, variable, and one or more nominal, ordinal, interval or ratio level independent variables. 2. Comparison tests. These tests look for the difference between the means of variables. Comparison of means. T-tests. T-tests are used when comparing the means of precisely two groups. Example: the average heights of men and women. Independent T-test. Independent T-test tests the difference between the same variable from different populations. Example: comparing dogs to cats. ANOVA and MANOVA. ANOVA and MANOVA tests are used to compare the means of more than two groups or more. Example: the average weights of children, teenagers, and adults. 3. Correlation tests. These tests look for an association between variable, checking whether two variables are related. Pearson correlation. Tests for the strength of the association between two continuous variables. Spearman correlation. Tests for the strength of the association between two ordinal variables. It does not rely on the assumption of normally distributed data. Chi-square test. Tests for the strength of the association between two categorical variables. Dealing with non-normal distribution. Although the normal distribution takes center part in statistics, many processes follow non-normal distributions. Many datasets naturally fit a non-normal model. Example 1. The number of accidents tends to fit a Poisson distribution. Example 2. The lifetimes of products usually fit a Weibull distribution. Example of non-normal distributions: beta distribution, exponential distribution, gamma distribution, inverse gamma distribution, log normal distribution, logistic distribution, Maxwell-Boltzmann distribution, Poisson distribution, skewed distribution, symmetric distribution, uniform distribution, unimodal distribution, Weibull distribution. Well then, how do we deal with non-normal distributions? When your data is supposed to fit a normal distribution but doesn't, we could do a few things to handle them. We may still be able to run parametric tests if your sample size is large enough, usually over 20 items, and try to interpret the results accordingly. We may choose to transform the data with different statistical techniques, forcing it to fit a normal distribution. If the sample size is small, skewed, or if it represents another distribution type, you might run a non-parametric test.
If you have any doubts regarding this topic, please comment down below. I will respond as per my best. Signing out.